All right, hi, good morning everyone. Thanks for joining us today. I hope you guys have been enjoying this year's AWS reInvent thus far. Thanks to AWS for giving us the opportunity to speak a little bit about ScyllaDB here today. And of course, I would like also to express my deepest gratitude to both SAS and Freshworks, both for their continued partnership, as well as taking the time to share a bit of their story with us here today, all of which you are going to hear about just shortly. My name is Felipe, and I work as a technical director at ScyllaDB. So just to set the scene here real quick, I want to briefly recap the primary challenges teams face when they try to scale their data-intensive applications. These are applications that require extremely high throughputs with fast and consistent response times, often within single-digit milliseconds or lower for their tail latencies. As data-intensive applications scale and become critical for your business, the primary core challenges is ensuring their consistent performance. As you scale, conventional database systems become increasingly sensitive to traffic fluctuations, which, yes, you can try to mask by throwing more money at the problem, but that quickly becomes unsustainable in the longer term. And this is really the context where ScyllaDB fits in. ScyllaDB is the database for for applications that require predictable performance at scale. Our architecture is specifically designed to eliminate performance bottlenecks that conventional database systems struggle with at scale. Rather than compensating with more hardware, ScyllaDB is close to the metal architecture, is built to maximize the performance of underlying infrastructure. That's why organizations trust ScyllaDB to power their most critical applications. With ScyllaDB, a small 3-node cluster running on top of AWS EC2 is capable of sustaining millions of operations per second with predictable single-digit millisecond latencies, even as workloads grow and fluctuate. This efficiency does not just improve performance, but considerably reduce infrastructure costs, giving you headroom to scale your most demanding data-intensive applications. So, how do I know whether ScyllaDB is a database that's a good fit for me? First, if your current response times are unpredictable, especially when your tail latencies are starting to violate your SLAs and your teams keep getting paged at 3 a.m. just for you to babysit the database. Second, if your database cannot keep up with throughput demands, particularly during peak or spiky traffic, or when you are forced to over-provision just to stay ahead of unpredictable load because your system lacks true elasticity. And third, your database spend is spiraling, and adding more nodes, replicas, or caches has become the only way to mask the performance issues which end up driving your costs out of control. If any of those 3 points or a combination of these resonates to you, then you may want to check out on ScyllaDB. So this chart on this slide demonstrates our user base spectrum, where the y-axis represents throughput and the x-axis represents latencies. As you can see, the largest cluster of users really live in the top left-hand side, with workloads ranging close to 1 million operations per second, requiring between single-digit to less than 20 milliseconds P99 response times. Now, why ScyllaDB? Our highly available architecture allows teams to confidently run mission-critical applications at scale. We are built first and foremost with high-performance transactional workloads in mind, while we still support real-time analytical use cases that need fast access to operational data. And more recently this year, with our recent native vector search, ScyllaDB becomes a unified AI platform built for performance. ScyllaDB can store and serve massive volumes of data while using fewer nodes, reducing infrastructure costs and operational overhead. It's also designed to avoid vendor locking, giving you the flexibility to run your workloads on-prem, in any cloud, or in a hybrid environment, and effectively allowing you to serve data closer to your users where it matters. Elasticity is also built deep, very deep in our architecture. We allow clusters to scale with demand, eliminating the waste of permanently over-provisioned infrastructure. So you get predictable performance during traffic spikes and cost efficiency the rest of the time. So, how are organizations using ScyllaDB today? Beyond SAS and Freshworks, at last year's reInvent, I had the opportunity to speak along with TripAdvisor here at this very same reInvent, who shared how ScyllaDB powers their real-time machine learning system for recommendations. We also have companies like Discord, who use ScyllaDB at massive scale to connect millions of users in real time around the world. Disney Plus and Hulu are relying on ScyllaDB to power their media streaming services. ScyllaDB having supported the Super Bowl for actually many years in a row now. We've got that far, yeah. And of course, most of the organizations listed here actually also run ScyllaDB within AWS, which makes it perfect for me to talk a little bit about our existing partnership with AWS. ScyllaDB has been, for many years, an AWS ISV partner, where we've partnered together in demonstrating the superior price performance of their EC2, I4I, and I7I instances ahead of their launch, as well as the superior Graviton performance also in AWS EC2. We are a Graviton-ready partner, and we have two listings in the AWS marketplace. We have ScyllaDB Enterprise for users who want to run and self-manage their own database deployments, and we have ScyllaDB Cloud, our fully managed database as a service offering. So, with that, let me switch over to Brian Jones, Senior Manager of Software Development at SAS, who is going to tell us a little bit about SAS real-time personalization story. Brian, thank you so much for sharing your story with us today. And with that, the floor is yours.
All right. Thank you, Felipe, and thank you, everyone, for coming to this presentation today. So the first thing I want to do is talk about the big game. So you're sitting down watching the big game, and suddenly there's a break in the action, and now you get an advertisement, and it happens to be the same commercial you've already seen in the previous break, and that's very annoying for you. Why does that happen? Well, they are probably not a customer of SAS. At SAS, we've been delivering digital advertising during live sporting events like football, soccer, tennis, rugby since 2014. We have a robust ad tech platform, seamlessly integrating with your own data, workflows, and partner ecosystem. Good ad decisions require us to activate data quickly, which improves the outcomes for both viewers, advertisers, and broadcasters. In plain terms, the core of video advertising is composed of a few parts. The first of these is ad decisions. When we receive an ad request, we need to make a decision quickly about what to serve. And that response in video advertising uses the IB VAST standard, which will include some playback signals or events. So as the advertisement is played out, these signals become back to SAS, other partners, and those become then part of the reporting that broadcasters and advertisers will utilize. And finally, especially for video on demand, optimization can happen where you can choose how many ads to show or how long a break should be for individual users. So this picture is from inside the Ocracoke Lighthouse. You can take a look inside of there during summer months. And like the steps to summit this lighthouse, there are a few challenges in digital video advertising I want to discuss. So first, you need to scale to support large traffic spikes. integrate with the rest of the ecosystem, and make advertising relevant to each viewer. So at SAS, we help organizations do amazing things with the data, and we've been doing it for nearly 5 decades. SAS is a leader in data and AI with headquarters in Cary, North Carolina. Our focus is on helping people to use data and AI responsibly and effectively. SAS 360 Match delivers decisions at scale for our customers around the world. So these are some of the numbers: billions of impressions, video ads, programmatic bid requests, and all delivered with low latency and high availability. So this image captures part of the new user interface for SAS 360 Match that I and my team have been working on at SAS. It is a first-party ad server delivered as software as a service application to publishers, broadcasters, retailers, financial institutions. And we have clients like desktop browsers, mobile applications, connected TV, and many other platforms. So I work on essentially all aspects of this product: R&D, operations, security, governance, legal, audit, et cetera, et cetera. So if you have questions, come talk to me afterwards. So what kind of data do we usually have when we're making a decision? So we have personal data, like where are you, your interest, maybe some data that you use to sign up for a service, registration data. There could be analytics scoring data that's also attached to your identity. Additionally, there's contextual data. Amazon has spoken about this for a couple of years now, using AI to grab contextual data from video streams in advance or in live. So you have episode data, break data, also recent ad serving history data. Then we also can incorporate other data. So there could be product data or potentially offer data. So from all of this data, audiences and segments are created that appeal to advertisers. So there are many methods available to provide data for decisions. An ad request may provide this data. The data could come from an external web service. For example, if you need to get the current weather for a location based on geo, that data is fetched, used, cached for a brief period of time, and used for that request. You can also reference data that we hold in memory or is stored in a persistent data store. And any of this data could refer to other identifiers, which will load more data for you. And recently, as of earlier this year, we introduced the concept of data sets, which is basically a hierarchy of identifiers where we evaluate each set of data independently to determine what should be served. So let's dig a little bit into an ad break. So when a video stream is approaching an ad break, there will be a signal within the stream, SCUDdy's type of signaling, indicating that a break is coming soon and we need to make an ad request. That ad request is usually templated. It doesn't usually have very much data, a couple of things at most, usually. And we'll receive this, and then we'll need to make a decision about what to serve. And so we'll return a vast formatted XML template response. And inside of this, it'll have a number of these events, which I mentioned earlier, like impression, view, various standard quartiles, those sorts of signals. And this is an example of what the break actually looks like to our software. It's a series of requests. In this example, we have a duration server request. It's asking for a duration of 180 seconds. It says it needs that this is the particular break identifier. This is like a pseudo-random identifier. It'll recycle after a couple months probably. Then we have an identifier of some name for a visitor, so in this case SVID. And then after this add request returns the VAST response. The server-side add insertion or the player device, whatever, will begin making these count requests. These are all the events that were in the VAST response to begin with for all the quartiles that we mentioned before. So then how do we make a decision? Let's dive a little bit through that. So if we've never seen a request from a user before, from a visitor, we're going to need to start a session. So we will start the session usually with an identifier that's given to us, but sometimes we'll need to generate one. We'll then load data if we have it for the individual, if we've got data to load for them, including all of their previous history that we need to enforce other business rules. And then we can begin processing the actual request. So we'll activate more data. So super tags, these are in-memory data, sometimes persisted data from identifiers, usually coming from expansions of things that are inside of the request itself. Then other identifiers may be loaded. Remember the products and offers that we talked about earlier. Connectors are the things where you can talk to any HTTP web service, load more data still. You can also talk to SAS intelligent decisioning. Then we need to make a decision. So the customer can introduce prioritization based on their needs for their inventory. SAS can perform optimizations as well as targeting via Boolean logic on all of this key value data that we have in hand. And if the customer is using it, we can talk to OpenRTB, SSB for open web creatives, or they can make use of direct bookings in the system as well. So once we have selected the creative, we'll render a response, again from the VAST template for video advertising. We'll serve that and record this decisions, one or more, as well as metrics that need to be generated. So providing the best decision in the moment also means that we support the viewers. For example, by preventing the exposure to the same advertiser or ad too often, ensuring that industry and government regulations are followed, and respecting the privacy rules and regulations our customers must adhere to. So at SAS, we approach things differently than many other players in the digital video advertising industry. SAS does not collect and aggregate data across customers as others in the advertising industry often do. So the broadcasters have control over their data and with whom that data is shared. We provide our customers with the tools that are open to integration and extension to fit their needs. Both performance and availability matters not just for users, but also advertisers and our customers. How do we scale our access to data? We require, this is a requirement, that the database have low latency reads, that it must have high availability, data redundancy, and predictable cost. But there's not enough time during this cycle of add request to fetch the data, make use of it, and make the changes and write them back out. So we introduce some other concepts. We activate the data on session start. We write changes to the data when necessary. And this reduces the interactions necessary for sessions. They are routed based on to find the right session within the cluster. How do we scale to handle large traffic spikes? So we make use of load balancing. In Amazon, we've been using provision capacity from load balancers for many years. It went GA earlier this year, I think in January, maybe December last year. We also make use of auto scaling. Previously EC2, now Kubernetes horizontal pod autoscaling. Scheduled scaling is also available, so broadcasters often know or have an idea of the size of their audience based on time of day, program, etc. And we also introduced CPU utilization buffers, so rather than run at, let's say, 80% CPU utilization, maybe you run at 50%. You give yourself some room to handle spikes that autoscaling simply can't do. And finally, load shedding. So there are several features in this area. In one case, a customer can choose to prioritize certain types of requests over others. So because some are more important to them for revenue than other requests are. So I've only touched on part of what SAS 360 Match can do and how it does it. We support many kinds of client applications. We use many Amazon services. And yes, we use ScyllaDB. So why do we use ScyllaDB? ScyllaDB provides the low latency that we need for reads. It linearly scales both vertically and horizontally with compute. Individual nodes in the cluster can be replaced without data loss or downtime. The data can be replicated to multiple data centers, AZs, or regions if needed. And for us, we can also use workload prioritization to ensure that ad delivery is not impacted by other data processing that we must do. Here is an example of what a request spike looks like. So when we get to a spike seen on the bottom graph, there's essentially no change in read latency, which is exactly what we want to see. What kind of data do we store? So we store viewer data, registration data. This includes events for event counting. So we know how many times you've done something that's important to the broadcaster or advertiser. We also can store exposure. So this is how many times you've seen a particular ad. And there are rules that will say things like, let's not show this ad more than once a day. Those sorts of things. Additionally, there is data that can help map from one identifier to another, if necessary. You can see this for cases where you only have a device identifier, but someone is signing in as a registered user, and so the device becomes associated with the registered user in this service. We also make use of additional data like the program and episode data, break identifier data, product and offer data. So it's one thing for me to talk about what SAS 360 Match can do. It's another to hear it from one of our customers. So Alex Maison, head of digital ad platforms at ITV, says the following. The flexibility of SAS 360 Match allows us to develop things at our own pace. We define our own development queue. We're not waiting for a third party. What this means is that Alex can often use the existing capabilities within the toolbox that SAS provides to solve new problems without waiting for new development. All right, if there's just 3 things to remember from my presentation, here's what they are. With SAS, you can leverage a multitude of data sources to make the best decision at the moment. You can help advertisers reach their intended audience and provide broadcasters with the tools to improve the advertising experience for viewers. And SAS does all of this at a scale that can handle some of the largest events in broadcast sports. All right, I'm going to turn this over to Felipe now.
Thank you so much, Brian, for such an awesome talk. Before we let you go, allow me to ask, you spoke quite extensively about the SAS 360 suite. Is there any particular examples of problems ScyllaDB helps you solve?
Sure. So in ScyllaDB, I mentioned event counts. So in one case, a customer had a satisfaction problem where viewers were unhappy that when they went to go watch a video on demand stream, they were shown advertisements. And let's say they didn't actually want to watch that one, they wanted to switch and watch another one. And then they get ads again. Well, why? There's a way to fix this within the ad software itself. So we can count when you have last seen ads, a break for instance, and let's say you want to implement a rule that says if another ad request comes within 4 minutes of the last time you saw ads, we're going to skip it. We're just not going to do it. And this greatly improved user satisfaction for this broadcaster. It was a very small change to make that had a huge impact.
And from that perspective, would you say ScyllaDB somewhat sits in the hot path, critical path on your application? The way I like to frame it is, ScyllaDB were ever to come down, what would be the impact to your SaaS business?
Well, Scylla doesn't come down.
Yeah.
I mean, it's not a thing. Too much redundancy. Scylla is critical for us for data redundancy and ensuring we have the data we need quickly when we're trying to make an ad decision, especially in like the worst case scenarios where it's a new user, we've not established a session yet, and so we plan for those contingencies and ensure that we have the resources necessary with Scylla to answer those requests.
Well, thank you again, Brian. Brian will be available later after our presentation to answer any questions you may have. With that, Brian, I will let you go. So, during his presentation, Brian spoke about SAS 360 Match API support, both real-time and batch updates to data. He also mentioned about one particular ScyllaDB feature called workload prioritization. That's a feature that allows users to assign different SLA priorities for different workloads. In that sense, that's a feature geared towards infrastructure consolidation, which allows you to prioritize real-time workloads in contrast with workloads that do not have strict latency requirements. So, next up, allow me to call Sreedhar, VP of Engineering, and Prem Kumar, Senior Manager at Freshworks, who are going to share their story on how Freshworks redesigned their AI software architecture for 10 times growth while improving latency by 95%, all of which with under significant cost savings. Sreedhar and Prem, thank you again for your time, and with that, the floor is yours.
Awesome. Thank you, Felipe. Hello, everyone. Good morning. This is Sreedhar Gade, Head of AI and Data for Freshworks, and it's Prem, my colleague.
Hi, myself Prem Kumar. I handle the Dataverse at Freshworks, Data Platform Engineering. My passion is data, and that's what I live for.
Fantastic. So, over next 20-25 minutes, I'm going to cover this presentation in 3 parts. I'll call Prem back into the stage, during the initial part. Thanks, Prem. So the first part would be about Freshworks. Essentially, we talk about the company and its scale. That will be a good segue into section 2, which is about the entire journey of our NoSQL, the quest to actually find ScyllaDB as one of the great partners, and then how did we actually go about building multiple use cases, and then our migration story. Then I'll come back again and wrap up with the AI use cases and then takeaways. So that's us. And so Freshworks is a company started about 15 years ago in 2010 in a city called Chennai in India, with the dream of building an uncomplicated software to enable companies to solve their business workflows easily. And we started as a Freshdesk, which is a customer support software, and over time we went on to build just the dream that we had about like building uncomplicated software for all sizes of companies. And 10 years later, we were the first company in a SaaS field to have gone public in the US, right? And we are very proud of that. And now we have close to 75,000 customers, and we serve our products in over 40 different languages, and touching distance to 1 billion revenues across, and we're very proud of that. And how did we build that? We always looked at the customer side, how do we create uncomplicated software, but at the same time, we also look at uncomplicated technology stack. So you'll see there is a foundation at the bottom where you have cloud infrastructure scaling across, and then you basically will have the platform, which is all the foundational capabilities like say single sign-on and then analytics and everything else, and on top of it you have again foundational AI, and then you got the products on top of it. So this helped us scale leaps and bounds, and we are just getting started. And the journey has been fabulous for us. Like I said, in 2010 we started with a product called Freshdesk. We were a single product company, and with a humble 100 to 200 customers. But then soon we started adding Freshservice. Freshservice is our IDSM offerings, and now we have today we have asset management and service management and even the employee workflow management also in this, and this is one of the fastest growing ITSM systems on the planet, on the SaaS world. And as you can see, we also have Freddy, which is our brand name for the AI offerings across the company, and then you will hear a lot about Freddy as well in the upcoming slides and outside. So that's about Freshworks. So Freshworks, in summary, it's a company that was built to revolutionize the experience for SaaS customers, and we did just that. But then that also basically means that we keep reinventing the data technologies and AI technologies to meet and exceed customer expectations. So let me talk about, double click into the data side of Freshworks. So one size does not fit all, right? So we moved from having entire business logic into MySQL or RDBMS to multiple data technologies across the board, and whatever actually fits that particular use case. And at the same time, we wanted to make sure that whatever we have in our Dataverse portfolio is the best in that space, and that's where our whole partnership with the ScyllaDB actually comes in, and that's what we are going to talk about. So we care about data engineering. So it's not about operations, or it's not about keeping things up and running. It's not about keep the lights on. It's about engineering for data. Second thing is we care for reliability and scale. We spoke about scale already, and reliability matters. We at Freshworks, at a Dataverse layer, we give 4 nines consistently, at sometimes 4.5 nines as well for all the products being supported by that. We also care about disaster recovery and BCP, and also data residency. The customers are increasingly more sensitive about where their data is, and also how up and running in terms of the disaster recovery in case of outages that happen on the cloud or elsewhere. And security is paramount for us. We care for the privacy and security of our customers' data, and that's where data, since that entire Dataverse holds the source of truth as well as the persistence of data, we want to make sure that the security is ground up, data at rest, data in transit, everything is kind of encrypted and secure. Last but not least, we also have close to 1,000 plus developer community in the company for us to support, who build applications and products and AI on top of Dataverse, and we give them AI-enabled self-service portals for them to be able to spin off data layers and then be able to scale, support, manage, deploy everything else. So it's very seamless, and it actually helps them also scale. So that's a glimpse of Dataverse at Freshworks. Right? Now going deeper into how we came about our ScyllaDB journey. So we have been talking about Cassandra workloads, and there are multiple NoSQL use cases within our company. You'll hear more about those use cases. We kind of open up our playbook for you in a way, selflessly, to talk more deeper into exactly what are those use cases and how it kind of helped along with scale. But in a nutshell, Scylla kind of allowed us to actually bring our own AWS accounts, because we are a super complex AWS environment already in a mesh architecture with the platforms and AI and applications. So we did not want to change that. So we were actually in our own VPCs, but actually we could bring in Scylla into our tech stack, but still have all the goodness of hosted solution. And you'll also see performance and scale metrics. You'll see, like I said, use cases. I think you'll be able to resonate with some of those as we speak. And but what's more important is how did we migrate with a third-party Cassandra or open source Cassandra to where the Scylla is, right? And how how was the journey? You'll also see that. And last but not least, there are also some future upcoming use cases that we are talking about. This world is all about AI. So everything to do with AI and how we are empowering using self-service or agentic workflows, how Scylla is going to actually help us get there, right? Like I said, our customers care for data residency, and that's one of the reasons where while we use managed service, the entire data plane is within our own VPC. We have full control over it, and then we have full access to it, and then it is actually within the boundary of our security guardrails. And the control plane is with Scylla, and there's a perfect combination. And it really helped us quickly deploy, quickly scale, and take it from there. And this is, I think, a defining slide, because if you look at the numbers there, when we actually did the benchmark, when the executives from Scylla came and met us in Chennai and said, hey, we are this company and we actually solve Cassandra problem. I said like, hey, this problem has already been solved. Apparently not. So when we actually looked at it and then did the benchmarks, and we were just blown away with the, especially tail, the performance is like much higher at P 99.99 percentile. Right? We generally look at P90, P95. Here we are looking at that depth, which means that no single request is actually left behind in terms of the performance. So that was our experience. And so with this, I basically hand over to Prem to actually walk us through some of the use cases. You can actually go through it, and then I'll come back and wrap it up. Prem, over to you.
Thank you, Sri. I'm going to talk about some of the use cases at Freshworks. We use ScyllaDB. So I'm going to cover 3 different types of database migrations as well along with this. So the first one will be covering Cassandra to ScyllaDB, which is a natural migration for us to consider. And the second one will be like how can MySQL data to be moved towards ScyllaDB. And the third one will be DynamoDB data with limitations kind of improved while we move towards ScyllaDB. So Conversation Store is a platform service at Freshworks. This kind of covers all the conversations, kind of stores all the product conversations at one shell, and then this kind of also as translation service. This can also be useful for us to store the AI conversations between customer and AI agents. And this is powered by Cassandra. And we also have UCR, which we call as Unified Customer Portal. Like we kind of actually store all the contacts, whatever that is part of all these products like Freshdesk and Freshservice in one place, and we also retrieve it on a very low latency level. So that's a requirement. So we were using Cassandra for this. There were some bottlenecks in that and also some availability issues. So we did consider ScyllaDB for that as well. And as I said, the scale is kind of 4 billion plus contacts saved in this portal, and the expectation is very minimal, right? The latency should be below 5 ms consistently, like it should be even P99.99 should be also below 5 ms. And the current scale is 15K ops per second in this portal. So I'm going to walk through the migration story. And as I said, we had some difficulties in Cassandra, like every weekend whenever repairs runs, deletion runs, we had fallen to some latencies and also timeouts in Cassandra. And also we did try some third-party Cassandras like DataStax. There were some availability issues. So we did consider ScyllaDB for this particular action. And I'm going to walk through the migration story, which is kind of a little interesting for us to, and also challenging for us to push our limits, because we want to do this in a live migration, because we wanted to give the customer the ease of continuing the use of database and applications even in the weekends. So we cannot afford any downtime. And that's our benchmark. We wanted to make sure the customer is always up and able to serve, because we serve across all part of the country, right, and also all part of the world. So customers, we kind of push our standards that we ensure that there is a zero downtime migration always. And we kind of taken the Freshworks application and introduced a ZDM proxy in the middle of Cassandra, which can actually do dual writes for us for both Cassandra and Scylla. So while it does dual writes, the reads goes through Cassandra. That's our existing system. So when I say dual writes, all the new data, like when right from the beginning of the ZDM proxy gets captured in both the places, Cassandra and Scylla. And now that CDM migrator comes to migrate the historical data, like from where it left. So we started dual writes. Now we'll have to migrate the historical data into the new system, ScyllaDB. So we used a CDM migrator. We migrated all the historical data into ScyllaDB. And now that it has both historical data and the latest data through dual writes from ZDM. And this is very well put out here as well, like how the CDM migrator reads data and then pushes to ScyllaDB. And after we complete the migration, we also wanted to validate and then fix the missing gaps in terms of repairs and things. So we kind of actually used a CDM migrator to validate all the data is copied from Cassandra to Scylla. So while we do that, we find some of the gaps because the data we talk here is close to terabytes, like 1.2 terabytes to be exact. And we find some bottlenecks and the job is keep on running for a while. And then we kind of took the open source CDM migrator, modified with batch processing options. This helps us to kind of add the batch processing and improve the time to 10x. So one advantage what we have in this portal and this use case is this only powers majority of inserts, not much are updated. So which we can make sure that only if we check the record exists or not, that should be enough for us to cross through the validation phase. So we were able to get 10x improvement. And now this CDM migrator is upstreamed as well, and ScyllaDB is using for other customers while they migrate Cassandra to Scylla as well. And as I said, validation is completed now. We also go to we wanted to switch the traffic, right? And we kind of switch the traffic from, I think I moved the slide. Yeah, we kind of switch the traffic from Cassandra to Scylla at this point. Now while we do that, we want to ensure the reads are switched first and then validated through logs for any errors or any timeouts and things like that. While we are comfortable, then we kind of moved the write traffic also to ScyllaDB. And we also ensured that after the write is switched, some kind of ZDM proxy dual write happens to Cassandra as well, because that gives us the convenience and comfortness for us to come back to Cassandra if there is any issues faced. But fortunately, there is just a one path. Once we move to Scylla, there is no coming back for us because the system was scaling what we expected, and we were able to always serve the traffic with the within the SLA. And the tail latencies were really helpful, like Steve mentioned initially. And I move on to the next use case. This is workflow automator use case. So when I say workflow automator, this is going to power all the workflows that runs across our systems, all the products and all the platform services, all the AI use cases. So this is a born use case with Scylla. There is no migration involved here. The Scylla was directly supporting this. And the uniqueness is this have multiple concurrency, and we have close to 250K plus workload workflows stored here, and parallel executions has to happen. And this is operating on the top of Netflix connector open source software that demands a Cassandra backend. So we kind of selected Scylla because the throughput is very high, and now AI coming into picture, there is a lot of even more further workflows that has to be run seamlessly and optimized. So we selected ScyllaDB for this use case, and it is being served very much in ease and also within the latencies, as I said. So moving on to the next one. So I have covered the Cassandra to ScyllaDB story. Now I'm coming towards what we wanted to migrate from MySQL to ScyllaDB. So Freshworks historically is a MySQL come Ruby store. So we say the source of truth lies in MySQL. So while we say that, we are able to handle the scale today because we are able to, we are always thinking about handling next 5 years, what can happen and what will be the scale. And we want to see to that this scale has to be supported, as I said, without any downtime and without any customer latencies and without any, with all the new features coming up with the AI and things like that. We want to deep archive and things like that. So we thought to move the text and blob data that is saved in MySQL today. That takes close to 2 petabytes of data for us because all the conversations, historical conversations lives in conversation store, but again the tickets and ticket bodies data lies in the MySQL at this point of time. So we felt this is only a lookup content, there is no filtering or anything on the top of this. So this can move to a different store. We evaluated multiple stores for this particular operations and this particular use case. And we finally felt ScyllaDB is again offering this low latency, and also due to the reliability and availability and scalability options which they have, we felt this can also fit into ScyllaDB. And while I talk, the problem which we face today in MySQL is we wanted to upgrade the systems pretty often, like 6 months once today because of the UOL kind of situation. And to migrate these petabytes of data without downtime is becoming more and more challenging. And whenever there is increased workloads from customers, like they wanted to process some historical jobs and they wanted to process some historical contents, and due to some Cyber Monday deals, the traffic increases, we'll have to scale it on the ease. And all this becomes little complicated in the relational database world. But this is what is Scylla going to help us in benefiting. So there are two advantages. So we kind of bring the MySQL storage lesser, which means we can handle the MySQL store which with more further easiness, and also we can scale up, scale down, replication and all that will happen within the SLA. And on the other end, like where the majority data is going to shift towards Scylla, we can actually scale seamlessly, vertically, horizontally in however fashion we want, and also do version upgrades, patching without any downtime. So this is the advantage we see. And while we see that, we also wanted to migrate the petabytes of data, right? And it's not going to be a direct option. And we have the same challenges like incremental data and also the historical data migration that has to be done here. And while I say that, we kind of selected Kafka approach for this, for the CDC changes, the incremental changes, and then historical data comes through as Parquet format. So, and while I talk about this, I'll also need to, yes. So we need to do 2 petabytes of data migration here, as I already said, and we kind of use Kafka Connect, Debussium backed CDC options from MySQL. This will copy the bin logs into Kafka through events, and then save all these incremental changes, and that can be put into ScyllaDB through ScyllaDB string store. So this will actually, again, part of the Kafka Connect built by Scylla's team. This sync store will actually, sync connector will actually read all the data from Kafka and pushes to Scylla seamlessly. So the incremental data comes in, and the MySQL, from MySQL we'll use the S3 export option to Parquet, and then Parquet files can be loaded into Scylla directly, and then we will validate using our custom Lambda solution so that the data present seamlessly, and we'll switch the read traffic initially to make sure that the read things are happening and processed fine with the Scylla systems, and then we'll switch the write traffic seamlessly. So that's the plan we have. And I've already covered MySQL use case and the Cassandra use case. Moving on to the Dynamo use case. Today our activities microservices, it sits on the top of Dynamo. So while I say activities, it's another use case number 3, which we actually see some limitations because of the size, right? The item size in Dynamo is limited to 400 KB, which is actually pushing us to split it and then write it into Dynamo store. Dynamo is fine, that's completely cool. It's great to use as well, but again, this limitation pushes into multiple options, like we'll have to split it into multiple records and then write it and then fetch it again. All these logics are handling some compute throttling in our compute layer. So we wanted to see if we can migrate this to Scylla, because the limitations are not there as such. And also, we want to scale this further and also be FedRAMP compliant and things in the future. So we selected this particular option, and for this again we thought to migrate both historical data and as well as the incremental data. Pretty much same approach like MySQL, but different connectors are used here. So we kind of enabled the Dynamo streams here. So Dynamo streams will actually have the change data capture in Dynamo, and from there we kind of actually use our custom Lambda to read these events from DynamoDB and push to Kafka events. So this will actually take care of the incremental changes, as I already said. And this incremental changes will be taken to ScyllaDB, like using the same sync connector that is provided by Scylla team itself. And then data resides in Scylla at this point, and the historical data will be taken from the Spark job this time. We'll run a Spark MapReduce and copy the data from historical data from Dynamo to ScyllaDB, and then move the traffic to Scylla, like the way same switch like read and write. So this is well called out here in 4 phases. The first phase covers migrating the schema from Dynamo to ScyllaDB, and then we'll also enable the Dynamo streams. As I said, that's what is called as JDB CDC dual writes. So this will take the data to Kafka, and from Kafka we'll have to take it to Scylla. That is covered in the phase 2 and phase 3, and then we'll also cover the check sync validations, right? That will happen through our custom Lambda, and then we'll also do the read and write switch periodically. So with this, I hand it over to Sri to cover the next feature use cases at ScyllaDB for Freshworks. Thank you. Thank you, Sri.
All right, thanks, Prem. So just to wrap it up, it's not just the traditional MySQL or these use cases, but we are going forward. We are going to have more doubling down on AI. So what are the different use cases we are talking about? So there are two specific use cases that we are looking at going forward. One is something called, we are talking about like a feature store, where essentially like most of your features, most of your, the use cases are trying to reach LLMs, in some cases, trying to reach agents. So all these conversations are kind of cached in ScyllaDB. So that way, your traffic between your app and the LLMs are actually kind of reduced. Essentially, the overall round trips depend upon the performance of LLM as well. And when you make multiple calls, that kind of will be like a very noticeable latency. So this is one caching use case that we are looking at. So basically, ultra low predictable latency. And the second one is we are talking about like a feature caching as well. So yeah, this is the one I was just talking about, where how do you. So this is basically in between the you and the LLM essentially. So this is something we are yet to experiment, and we are hoping that I think we'll see some good improvement here. Next one is the data store for modeling. So this is more like an MLOps use case. So Freshworks has two sets of models that we use in an AI use case. One is generative AI, where we do not do any kind of training. We just go, this is Azure OpenAI and a few other ones. These are the large language models. We don't do any training. We just do inference with them. But we also have self-hosted models. These are smaller models where they are kind of optimized for some kind of a very specific use cases in industry verticals that we have. It's like something like IDSM or FSDesk. So these are the ones that we kind of train them, and these training cycles are becoming more and more frequent. And when we are working with this, we are also looking at to see how, can we actually have ScyllaDB in the training pipeline. So that way, Prem spoke about 2 petabytes of data. And all the data needs to actually go into this training pipelines. So how do we actually kind of do some kind of caching to speed this up, right? So and in the future, we are talking about like notification services. We are talking about URL shortening. This is again the 75,000 customers that we have. We led customers to have customer domains and create their own custom URLs. So in that space, how do we actually use ScyllaDB to create URL shortening service as well, and then attachment services. So yeah, essentially all the products that we have, fundamentally they are ticketing solutions, and they will also have ticket bodies and attachments. So till now we are looking at the MySQL alone, but then can we actually use this as attachment service as well? So ultimate takeaways. So as you have seen, Freshworks always reinvents the technology. Every single year, full stack, right? Whether it's a cloud layer, storage, compute, network, data, or it's the platform layer. We are talking about multiple capabilities like email, analytics, and single sign-on, or the AI or the products. And Scylla has been our partner in actually building some of these cool technologies, and they have been actually co-build partners and co-market partners as well. So we achieved, I think, 10x of what we thought initially that we would otherwise do. So it's always like awesome working with them. So with that, I'm calling Felipe onto the stage.
Thanks so much, Sri. You guys basically did a holistic view on all the value ScyllaDB gives to Freshworks. One particular question I have to you is, since you guys are running Scylla Cloud, and Apren spoke briefly about ScyllaDB Cloud and your BYOA setup, what's the main value BYOA gives to you as a customer, and for your customers as well? Because in the BYOA setup, all the data is still under your own management as well. Could you speak a bit more about that?
Yeah, no, absolutely. I think bringing your own account matters a lot, especially we are talking about. So Freshworks serves our products in 5 different regions, like US, Europe, India, Australia, and Middle East. And when we speak about it, customers also care for data residency. So they look at where their data resides and how it gets transferred. So we want to make sure all of our sub-processors also live in the same region, and the data doesn't go out the storage or in transit. So keeping all this in mind, when we are talking about bringing your own account, essentially our entire data plane resides within our account. So that actually makes it very easy in terms of access, scaling for our own engineers, right? And that could be a deal breaker for us. And since you enabled us with that feature, it made it so seamless for us to do the entire migration over to ScyllaDB.
Pran also spoke quite extensively about migrations and the different strategies you guys took. And I don't want to sugarcoat it. I mean, database migrations are hard. We often classify, we like to describe migrating a database like an open heart surgery.
Yeah.
How did ScyllaDB help it and simplify the process of migrating across multiple databases to ScyllaDB? How did your support team work with you guys and helped you guys throughout all the steps involved to move your data over?
Yeah. No, I think the analogy of operating on a patient is actually perfect. But we are operating on a patient where the patient is still in all the senses and actually not on an anesthesia or anything else. So our customers expect us not to go down at any point. They don't care whether you are doing maintenance or upgrades. They want the service to be up and running all the time, and that's one of the best features of ScyllaDB. Right? So we could do hot scenario where while the upgrades are happening or migration is happening, we could do parallel writes like Prem just spoke about it, and then reads progressively we kind of shifted based on the accuracy as we get more confidence. So that way, but if it is RDBMS, at least you'll have like a few seconds of downtime, and that is noticeable, for our customers. And then every time there is a downtime, we got to notify 75,000 customers 2 weeks in advance. And then if somebody says no, then in some cases, premium customers, you might have to even move the window. So in this case, it's like you're trying to maintain or replace the engines of aircraft while it is still flying.
Yeah. Thank you so much, Sreedhar, and thank you so much, Prem. I would like to tell you thank you for your continued partnership, and I hope we will help you out with this upcoming use case. So with that, folks, I would like to thank you all for attending and listening to both of our speakers today. If you liked what we had to share, please remember to rate our talk in the AWS Events app. And with that, if in case you have any questions to Brian or to Sri or Prem, we would love to catch you up here. And you are also welcome to visit our booth at the Venetian booth 1747. Thank you, folks, and have a great day.